Hey everyone, welcome to this explainer. Today, we're diving into something that literally affects every single one of us. At its core, occupational safety, it's not just some boring compliance checklist. It's actually this fascinating, complex, and absolutely life-saving equation. So that leads us right to a massive question, and it's really the core mystery we're going to solve today. How do we actually quantify danger before it strikes? Think about it. How do safety professionals look at a massive factory, a crazy busy construction site, or a volatile chemical plant, and somehow put a concrete number on all those invisible threats surrounding us? Okay, let's dive into this. Here's our roadmap for today. First, what is risk evaluation? Second, likelihood versus severity. Third, the hierarchy of control. Fourth, when protection fails, focusing on the Bhopal disaster. And finally, managing residual risk. All right, jumping right into section 1, what is risk evaluation? So, in the world of occupational safety and health, risk evaluation is really the foundational fulcrum of everything. Basically, it means evaluating the severity of a risk by rigorously weighing up the likelihood of harm against the severity of that harm. It's fundamentally a balancing act, a mathematical one. You're taking the exact probability of an event actually occurring, and you're actively multiplying it against the absolute worst-case scenario if it does happen. This specific calculation, it drives literally every safety decision we make. Now, to really grasp this, we've got to separate two words that we all use interchangeably all the time: hazard and risk. A hazard is just something with the potential to cause harm. A live electrical wire, a toxic chemical, a massive moving forklift. That's the hazard. But the risk, that's the mathematical combination of the likelihood of that hazardous event occurring and the worst potential consequence of that event. Think of it this way. The hazard is the what, and the risk is the how likely and how bad. Moving right along to section 2, likelihood versus severity. Let's start with likelihood. Now, you might think this is all about super complex algorithms, right? But actually, according to safety guidelines, likelihood isn't always some perfect, precise statistical probability. Rather, it's a really careful, balanced judgment. When safety experts weigh up all the relevant factors on a job site, they're really aligning their assessment to the concept of possibility. And we map that possibility using what's called a risk matrix. This tool visually maps out existing danger by assigning numerical values to those two core factors we just talked about. On the left axis, we've got the likelihood, ranging from very low to very high. Up top, we have the consequence or severity of the potential harm, going from, say, a minor scrape all the way up to a catastrophic fatality. By finding exactly where these two factors cross paths in the grid, an organization can assign a clear, totally objective numerical score to what might otherwise just feel like a really subjective danger. Now, what's really fascinating here is how frameworks like the failure mode and effects analysis, or FMEA for short, turn this whole concept into a strict mathematical formula. They calculate what's called a risk priority number. To get this number, you multiply the severity by the probability of occurrence. And then, this is the cool part, you add a third variable, the probability of detection. If a defect or failure in a system just can't be detected before it causes harm, well, that risk score multiplies exponentially. Okay, on to section 3, the hierarchy of control. So the universally accepted hierarchy of control prioritizes exactly how we handle risk, going from the most effective methods at the very top all the way down to the least effective at the bottom. The absolute best thing you can do? Elimination. Literally just physically removing the hazard entirely. If you can't pull that off, you move down the ladder to substitution, then engineering controls like machine guards, then administrative controls like worker training, and then, only as a very last resort, do you rely on personal protective equipment, or PPE, your hard hats and gloves. As we apply that hierarchy, we actually divide our controls into two totally distinct buckets: prevention and mitigation. Prevention controls are proactive. They're designed to stop an event from ever happening in the first place by reducing the likelihood of harm. Mitigation controls, on the flip side, are reactive. They acknowledge that, prevention sometimes fails, and they're designed to reduce the severity of the harm when things go wrong. It's kind of like this. Prevention is the brakes on your car, and mitigation is the airbag. And this beautifully illustrates the point. The bow tie diagram perfectly models our core equation. On the left side, you've got your hazard and your prevention controls acting as these barriers to reduce likelihood. Right in the center, you have the exact critical moment of loss of control. And then over on the right side, you've got the mitigation controls stepping in, trying to lessen the resulting harm and severity. Which brings us to section 4. When protection fails, Bhopal. Now, this rusted tank is from the Union Carbide plant in Bhopal, India. Back on December 3rd, 1984, this facility leaked deadly methyl isocyanide, or MIC gas, right into the surrounding city. It is a sobering, incredibly tragic reminder of the real-world consequences when safety layers are compromised. We're talking life or death here. When we look at the mechanical layout of the facility, the catastrophic failure becomes crystal clear. Almost none of the safety systems designed to contain a leak were actually operational. For instance, the flare tower's connecting pipe, which was designed to burn off leaking gas, had just been removed for maintenance. The refrigeration system designed to keep the liquid MIC cool completely shut down to save a bit of money on Freon. Even the vent gas scrubbers were turned off. Basically, the mechanical safeguards were methodically disabled. Safety engineers use this tool called a layer of protection analysis, and when you apply that to Bhopal, we see that literally every single layer of protection failed. The fundamental process design? Failed. The temperature controls? Disabled. The critical alarms? Entirely failed to warn anyone in time. There was absolutely zero automated safety system in place. The relief system, the flare, the emergency response? All of them failed. This demonstrates exactly what happens when an organization completely ignores proper risk evaluation and just strips away its layered defenses. Finally, let's look at Section 5, Managing Residual Risk. So we have to accept the reality of what's known as residual risk. By definition, this is the level of risk remaining after all your risk reduction measures have been implemented. Because look, human error happens, what safety pros call human reliability. And because work environments are just constantly shifting and changing, no activity is ever 100% risk-free. That's just a fact. So the absolutely crucial point here is how we document and respect that remaining danger before we even begin a task. A job safety analysis, or JSA table, integrates these principles step by step. You list the hazard, the existing risk score, the controls you plan to implement, and finally, the residual risk level. And here's the absolute golden rule of this document. If that final residual risk rating remains in the red, like scoring a 4 or 5, even after all your planned controls, work simply cannot proceed. Period. We know that risk appetite is the amount of risk an organization is willing to tolerate. But honestly, what is your organization's true risk appetite when the stakes are literally life and death? Are you actively evaluating risk by rigorously weighing likelihood against severity? Or are you simply ignoring the math and hoping for the best? Thank you so much for joining me for this explainer. Keep learning, keep evaluating the risks around you, and as always, stay safe.